Hi everyone. The focus of today's tutorial is just going to be to look how we can perform densitometry. Now, densitometry is a very powerful technique and it basically allows us to quantify this sort of band. So of course we can see that this band appears a bit darker than this one, which suggests that we potentially have more material in here, assuming we loaded the same amount of protein. But how many folds more of proteins do we have here compared to here? So this is when we need to perform some sort of quantitative analysis on this gel. Now, when you take a picture of your gel, of course, you use some kind of a machine that's associated with a computer. And typically the software in that computer will be able to perform the densitometry for you. What we are going to do today is to perform this densitometry manually to kind of understand what's happening behind the blinds, what's happening behind the screens, how the algorithms within those softwares actually work. Okay, so this is one of your gels. And what I did here was to open it in this software called ImageJ. And I like to use Fiji. Fiji stands for literally Fiji is just ImageJ. And basically Fiji has a bunch of extra algorithms and features added to it that ImageJ did not have. So ImageJ is kind of the stripped down version of Fiji. So first thing first, you open this in Fiji, you open your image in Fiji, then you go to image type 8-bit. You want to analyze the images in an 8-bit format. Okay, now let's say I want to quantify this band over here. Okay, so I need to tell the machine where my lanes are, and I need to tell it what exactly it is that I want to analyze. Now you're going to go ahead and select this rectangular tool. Okay, and you're going to look at the darkest band, so it's right here, and I'll tell you in a second why you want to do this, and choose a portion of this lane. And the way I'm choosing it is so the top of this box is kind of similar to it identifies the background. Okay, so you can see that this gray tone is basically the background, and this gray tone down here is basically background as well. And overall, this rectangle captures the entire band. And maybe I want to make it just a little bit smaller. Okay, just like that. But now what I want to do is I want to take this box and I want to carry it to my very first lane. Okay. Now the reason I did it, I measured the box, sorry, on the darkest lane, is because if you look here, this band is very fat because it has a lot of protein. This one is not as fat, so I want to be able to capture as much of this protein as possible without making it too big. So maybe just a little bit even smaller like that. So I'm capturing most of the band. So you can see right away that this densitometry technique, although it is giving you some quantifications, it's not the best quantification tool. Okay, so when you perform quantifications on your gel, you're really performing semi-quantification. So you can say that densitometry is a semi-quantitative tool, okay, because of the way it's performed on this gel, not because the densitometry itself is semi-quantitative. So now you take this box and you carry it over here. Okay, this is our first lane. This is our ladder, so we don't worry about that. And now what you do is you press Control 1. I believe if you have an Apple, you press Apple 1, I think it is. So Control 1. And this is going to put this number 1 here. But basically what it did was it added another box. So now you take this box and you carry it onto the second lane. And now you press Control 2. Okay, and you're going to take this box and you're going to place it on the third lane. And you'll note that on purpose I placed it a little bit higher, but when you press Ctrl 2, it's going to bring it down and kind of align it with the other boxes. Again, Ctrl 2, and you're going to place it here, Ctrl 2, here, Ctrl 2, here, and Ctrl 2, here. Now we have one of these analysis boxes sitting on top of each one of our lanes. Okay, so what do we do now? Instead of pressing Ctrl 2, now we're going to press Ctrl 3. And this is going to generate something that looks like this. Okay. So now we need to identify, so basically this is the intensity of the band versus area or versus spot. So this spot corresponds to this spot, and as you go down, of course you see the first intense band over here and the second intense band over there. These are these two peaks, and then you see a drop. This is basically these peaks over here. So let's say what we want to quantify is this peak over here, right where my number 1 is. So we know it's not this peak, but we know that this is this peak. Okay. So here, typically you perform densitometry on Western plots, so everything looks much clearer. But because we're performing it on the Coomassie blue staining, things are not as clear as I would have liked them to be. So the first thing we do is we identify where the background is. So the background is sitting right here, and the background is right there. We select the linear tool, and we're gonna connect the backgrounds. Okay. Now what we're going to do is we're going to identify the beginning of this peak. So this is this peak, right? So this begins right here, and we're going to connect it with that line. And we're going to do the same thing on this side. Okay, just like that. Two vertical lines. And now what we need to do is we need to quantify the area under this peak. This area corresponds to the intensity of this peak. Now, before we do that, we're going to do it to this peak as well. So this peak is much bigger. And of course, we need to do the background as well. And this is our peak of interest. Moving on. So here you see that the background is pretty good. So we captured the background pretty well here. So we don't need to do a horizontal line. We just need to do vertical lines. So this is 1, 2, 3, the first 3. Moving on, we're going to do the same kind of analysis to all of them, all of these lanes, just like so. Just bear with me here. Now this, what number is this? So we had 1, 2, 3, 4, 5. This is number 6. This is this one. So now we're getting into this really dark bands. So the first thing we want to do is we want to connect the background. So it's something like this. Now we want to identify our band. So once again, we know it starts right here and it goes to this point. You don't want to capture this one because this one is this band right down there. Okay. Now the reason it's so thick is of course because you loaded so much material. And now we want to do the same kind of analysis on this last well over here. So we do this. One vertical line, another vertical line, and we are done. So now we told the machine which peaks we want to quantify, and we're going to subtract this background. So this is all background here, right? So what do we do then? We're going to select this one tool, and we're going to click on each one of our peaks. And a new table is going to pop up, this table. It tells you the area under the curve, and it shows you exactly where the curve is. Okay, so second one, third one, fourth one, fifth one, sixth, and every time you're checking to make sure that it is just this peak and the area underneath it that's been captured. And the last one. Okay, so now we have all of these areas. Now these areas correspond to the intensity of these bands, and we need of course to check it to make sure everything makes sense. So you'll know that band 7 should have more intensity than band 6 if you look at the numbers. That's indeed the case. You'll know that band 2, for example, should be darker than band 1, and if you look at the numbers right here, band 2 intensity or the area is higher than band 1. Okay, and you can do this kind of analysis for all of the peaks. And this is basically your densitometry in a nutshell.